Okay, good afternoon, class. We're going to get straight into the lesson. If you recall, in chapter 4, we were speaking a lot about triangles and proving triangles congruent. In chapter 5, we're going to continue speaking about triangles, but we're going to speak about how it says here, the relationship within triangles. We're getting straight into section 5-1, which speaks about midsegments of triangles. So, what is a midsegment of a triangle? We have the definition right here. It's a key term in this section. It is a segment connecting the midpoint of two sides of a triangle. Okay, so the midsegment. If you have segment AB, and you have a point, let's say point C in AB, that makes AC congruent to CB, that makes C my midpoint because it's making the other two segments, it breaks it up into congruent. Okay. So getting back into the midsegment of a triangle, it connects two sides of a triangle. It connects the midpoint of two sides of a triangle. So let's say we have triangle ABC like we have here. Well, D is my midpoint. How do I know that? Because I see here that AD is congruent to DB. That makes D the midpoint of this side here. E is my midpoint of BC. I can see because I see that it's congruent, the two sides that that makes it up. That makes DE one of my midsegments. By the way, there are 3 midsegments in a triangle, which I will show you afterwards. For now, I'm just going to leave DE as my midsegment. Well, our first theorem in this section, which is 5-1, the triangle midsegment theorem, says if a triangle has a midsegment, really the theorem is if a segment joins the midpoints of two sides of a triangle, which by definition is a midsegment. So if there is a midsegment in a triangle, which is what I have here, then this midsegment is parallel to my third side, and it is also half the length of my third side. Okay, so I'm going to write that here as my then statement. Then considering this drawing, then that makes DE parallel to AC. They're now going in the same direction. They're parallel, my midsegment and my third side. And that means that my midsegment, DE, is now half the length of my third side, half the length of AC. Okay? So this is theorem 5-1, and like I mentioned, I was going to show you that there isn't just one midsegment in a triangle because there aren't just two sides of a triangle, there are 3, meaning AC can have a midpoint. So let's say the midpoint is somewhere here. Let's call this F. F is my midpoint only if I have, I'm going to draw this in a different color, if I have the congruent statement here, so I have the 3 sides here, the 3 sides there, that makes F another midpoint, which makes FE also a midsegment. FE in this case would be parallel to the third side, which would be AB. FE would also be half the length of AB, which also makes DF a midsegment, which makes DF parallel to BC, and it makes DF half the length of BC. Okay, so it's really important. I want to write this. The book doesn't show this, but I want to show you. If DE, if the midsegment is half the length of the third side, that basically means that 2 times the midsegment gives you the third side. Okay, I can easily do that by multiplying by 2 here on both sides, but I want you to see the relationship. If DE is half of AC, that means that AC is twice as much as DE. Okay, it's going to help you a lot in this section. So really quickly, just to show graphically why it is that a midsegment is not only parallel, but half the length of the third side. Let's say we have a triangle with C here as my point in the origin. We have A that has the coordinates 4, 6, so A is going to be somewhere here. Coordinates 4, 6, and we have B that's going to have coordinates 6, 0 here. So let's say we have the following triangle. and we want to find the midsegment. Let's say we find the midsegment D. I'm sorry, let's find the midpoint D, and let's make D the midpoint of this section, this side here of AC. Well, you guys know the midpoint formula. So D, if it's the midpoint of, let me write down, midpoint of AC is going to be, remember, it's essentially the average of the side. So this is my origin here, 0, 0. Oh, I just realized I made a mistake here. This here should be B. Sorry about that. So this is point B. So if D is my midpoint of AC, well, I need to find the midpoint. So I'm going to find the average of the x's, the average of the y's. So that would be 0 plus 4 over 2. And that would be 0 plus 6, the average of the y, over 2. 0 plus 4 is 4 over 2, we get 2. 0 plus 6 is 6 over 2, we get 3. So 2, 3 is my midpoint, and we see here in my graph, it's pretty accurate. So we have point D, which is my midpoint, which makes this segment congruent to this segment. And we're going to find point E that I want to be my midpoint of CB. If you guys see here, we just have a number line. Well, the midpoint of 0 and 6 on a number line is 3. So we have point E here. That makes CE congruent to EB. That means DE, my midsegment, based off the theorem we just learned, right, should be half the length of AB, and it should also be parallel to AB. How do I find that in a coordinate plane? Well, if it's half the length, that would mean that I would have to find the length of DE using the distance formula, the length of AB also using the distance formula, and compare the distances. I will see that DE is half the length of AB. I'm not going to show all of that, but I do want you to know or understand what it would mean on a graph. If you want more information on that, the book shows it really well. And not only is it half the distance or half the length, it is also parallel. How do I determine if lines are parallel? How do I determine if DE is parallel to AB? Well, I would find the slopes, okay? And they should have equal slopes because they're parallel. That I'll show because that's not too complicated. The slope of AB is a change in y over the change in x. So I'll make this 0 minus 6 over 6 minus 4. We get negative 6 over 2. We get a slope of negative 3 here for AB. For DE, I should have written down the coordinates. The coordinate of D is 2, 3. The coordinate of E is 3, 0. And again, the distance or the slope would be 0 minus 3. The change in y is 0 minus 3 over the change in x, 3 minus 2, which would be negative 3 over 1, which is negative 3. And they do have the same slope. Okay, I'm not going to show the distance formula, but I do want you to understand where or how this is true on a coordinate plane. So we're going to get started with problem 1. Problem 1 here we have triangle EDF, and we have here R, which I know is a midpoint because these two segments are congruent. T, that is a midpoint. I see that these two segments are congruent. And we have S, that is a midpoint because we have these two segments congruent. And now let's say that we need to find RS. And we need to find, the question is asking, what are the 3 pairs of parallel segments in triangle DEF? So let me write some parallel segments. Well, what we just said, R is the midpoint of this side, S is the midpoint of this side, RS is then parallel to this down here. So that's my first statement. Segment RS is parallel to DF because it's the third side and what we just learned from the Midsegment Theorem, which would make RT, my other midsegment, parallel to EF. And my last midsegment would be TS. TS would be parallel to DE. Okay, so it's not too hard. I'm gonna move on right away to the second problem, in which we find lengths. So you should have a figure that looks like this. We have triangle QRS, and we have the different midpoints here, where they tell us that T, U, and B are midpoints. Okay, so since it's given, we know that they're midpoints, and we're given the length of segment. So we have that SR is 40, that QS is 50, and that TB is 30. And we have to find TU over here, we have to find UB, and we have to find QR. So we have to find one of the lengths of the sides of the triangle. Well, using the midsegment theorem, I know that the midsegment is half the length of the third side, which to find TU, that would mean, let me write this in another color, that would mean that TU is half of the third side, RS. We already know that RS is 40, which would make TU half of 40, 20. So we found TU. I can use the same thing to find UB. UB is going to be half, right? UB, half of the third side, QS. Well, I know that QS is 50. Half of 50 is 25. And then we are finding the third side of the triangle. It's a little bit different. Remember, considering what we said about the relationship with the midsegment and the third side, if the midsegment is half the length of the third side, that means that this side is twice as much as the midsegment. Okay? Let me square this in. Which means that QR equals 2 times 30. Meaning QR equals 60. I'm going to show this using the same formula, meaning the midsegment, TB, equals half of QR. Well, TB is 30, equals half QR. I'm trying to solve for QR. I solved for it, but I'm trying to show you how you can use the same formula. You'll get the right answer. It's really the same thing. To solve here for QR, you multiply by 2, you multiply by 2. That way you get rid of that here. So you get that QR equals exactly what we said, 2 times 30, 60. So it doesn't matter what you use as long as you're being consistent, meaning the midsegment is half of the third side, or the third side is twice as much as the midsegment. Okay, moving on to problem 3. So we have a real life problem. So it's saying a geologist wants to determine the distance AB across a sinkhole. Choosing a point E outside the sinkhole, she finds the distances AE and BE. She locates the midpoints C and D of segment AE and BE, and then measures CD. What is the distance across the sinkhole? So essentially, we're using the midsegment theorem to find the distance across a sinkhole, a distance that we wouldn't normally be able to find, considering that what we said, D is a midpoint, C is a midpoint, and that DC, because it's not over water, is 46 feet. How can I find the distance across the sinkhole? Well, this is the third side, and based off what we just said using the midsegment theorem, that means that I'll use the formula that were shown in the book. Half of the let me start that over. The third side, or the midsegment, DC, is half of the third side. And I'm trying to find what AB is, or BA, because that is the distance across the sinkhole. I know that DC is 46. So to solve for BA, I multiply both sides by 2, like we mentioned before. This is essentially the formula that I said earlier, which is that the third side is twice the midsegment, which means that BA equals 2 times DC, we just said is 46 feet, which would make BA equal 92 feet. So the distance across the sinkhole is 92 feet. Okay, so that's essentially all for the first section of this chapter, the midsegment of triangles. Please let me know if you have any questions, and that's all.